Okay, this is topic 8, robot navigation. Um, the main aim is in robot navigation is to answer these three questions. Where am I? Where are other places related to me, and how do I get to other places from here? Even the question where am I is a very big issue uh, in by robot, especially when it comes to the navigation of a mobile robot. So to answer where am I is very difficult, very challenging. Um, we call it localization. To answer the question of these three is the term is used is what we call localization. Also, path planning. Path planning means how to reach the destination from the current location, and also how to perform the trajectory command in the path planning system. Another question is how is the place like and the structure of the environment the robot is operating in. There are many approaches to robot navigation. It can be classified into three main approaches. The first one is based on what we call geometric navigation, topological navigation, and also semantic navigation. They are different in terms of definition, but they attempt to answer the same question. Different approach, but trying to solve the same problem. Try to answer the same question. Component of navigation. So in order to answer the localization problem, the robot to have the ability to sense the environment, to perceive the environment, and to sense its surrounding. The main component in navigation is sensing. This is for sensing the environment, perception, and then the planning, and also the control. So robot use the sensor to perceive the environment, and perception is the process of interpreting the sensor data so that it understands its environment. Planning is what are the action will be carried out by the robot. It involve the sequence of action, and of course the control is the execution of the action to navigate. And localization is the process of determining the position of the robot within its environment, and mapping is the representation of the environment. So you have the localization and the mapping. Localization means determine the position of the robot. Mapping is representation of the environment. Okay, geometric navigation. It rely on the geometric reasoning. For example, in terms of distance, angle, the shape. This is geometric navigation. So when the robot try to perform localization in geometric navigation, we will apply geometric technique. So some of the sensor that can be used is rangefinder or odometry. So the algorithm like triangulation or feature matching can be used for localization. So this is localization in geometry navigation. How about path planning? Algorithm such as visibility graph and Voronoi diagram. These are the most common two algorithms that can be used for path planning in geometric navigation. Also sampling based planning. This one can also be applied. So visibility graph, Voronoi diagram, and sampling based planning. There are also deterministic algorithm. The main point here is randomness is avoided in deterministic algorithm. So potential field and Voronoi diagram are two examples of algorithm that are based on deterministic algorithm. So how the potential field, how it works? Let's see the diagram over here. So the idea is to have the, okay, let's say this is the environment, this is the goal, and this is the obstacle. This is the goal, this is the obstacle. So what happens here, the obstacle will produce a repelling force, whereas goal produce attractive force. So based on the value here, the robot will try to move away from the obstacle, but attracted to the goal. So that is the basic idea of potential field. So it differentiates the obstacle and the goal based on this energy, the repelling forces and the attractive forces produced by the goal. So we have a goal attraction and obstacle repulsion. Similarly, the field, once the artificial field is calculated, you will have something like this. So what happen is the obstacle will produce higher repelling forces. That's why you can have a path that move surround the obstacle here. So because the obstacle will generate higher repelling forces. So the path can be generated by moving or moving away from the obstacle. Now potential field is considered simple to implement. It is real time, and it is local planning, and it is suitable for real time obstacle avoidance and when navigating a dynamic environment. Dynamic environment means you have obstacle that constantly moving. The limitation is local minima. Sometimes the robot will get stuck in the local minima. This happen when not enough gradient is generated. That means there is no gradient over here that the path planning algorithm can follow. So the face is flat. That means there is no guide for the navigation process to move, whether to any direction. So this is what we call local minima. And also it need parameter tuning to make sure the strength of attractive and repulsive forces is sufficient for path planning. Now, how about a Voronoi diagram? So basically, it is simply by creating a Voronoi diagram. So the black color here is the obstacle. So as you can see, the Voronoi diagram can be used to guide the path from any position to any other position. So simply by following the line connecting the Voronoi diagram. And the question is how it is generated. So basically it uses the standard Voronoi diagram generation algorithm. So one way to generate this Voronoi diagram is to use Fortune algorithm or Delaunay triangulation. So you can use the Delaunay triangulation or Fortune algorithm to generate the Voronoi diagram. So this is the Voronoi diagram that can be used for path planning. As you can see here, very the line connecting the Voronoi diagram is a safe path that avoid the obstacle. Another example of Voronoi diagram. This is another. This one is generated using this one. This code will generate a Voronoi diagram given the two obstacles. The 4 obstacle here. 1, 2, 3, 4. Yes, you have 4 points here, and then you can generate the Voronoi diagram. Delaunay triangle. This one. This is Delaunay triangle. You can generate using this code. Okay, probabilistic algorithm. This one is contrast to deterministic algorithm. The one this algorithm, Voronoi diagram, potential field, Voronoi diagram, and Delaunay triangulation is considered deterministic. So probabilistic algorithm is considered undeterministic because of the element of randomness, the existence of randomness and probabilistic element into the algorithm. Normally this one is faster than the deterministic algorithm because of the randomness. It is much faster, but it does not guarantee to find the solution, even if the solution exists. A deterministic algorithm will guarantee to find the solution if the solution exists. Probabilistic does not guarantee that, but it require less computational resources compared to deterministic algorithm. Especially, it is more noticeable when it involves a very large environment. So one algorithm under the category of probabilistic algorithm is PRM. So it simply generates roadmap, very similar to Voronoi diagram. So the connection here is what we call a roadmap, but it is based on probabilistic, and this is why we call it PRM. So another example of PRM. Now, what are the advantages of PRM? In terms of scalability, it is more suitable to high dimensional communication space. Randomization is considered advantageous because it can handle complex environment. And incremental construction, that means if there are new sample, it can simply add it to the existing roadmap. So you don't have to recompute everything. So just add on to the existing roadmap if there are new sample comes in. Limitation of PRM, computational complexity quite high, especially when it involves high dimensional space. The quality of the roadmap can depend on the coverage, and it is sensitive to density of the obstacle. So another probabilistic algorithm is RRT, rapidly exploring random tree, RR3. Is the name, based on the name, it is this is RR3. So it generates a tree. Unlike PRM, this one is based on tree. So this one is also fall under the category of probabilistic algorithm. It is considered of efficient. RT is also incremental. Element of randomness similar to PRM. It does not guarantee optimality of the path, bias, and sensitive to the sampling and step size. Okay, GN is also involved in, you also use it for obstacle avoidance. Now, when it comes to representation, It can be occupancy grid. You can use point cloud or geometric primitive like lines and polygon to represent the environment. So geometric navigation rely on this representation of environment. Therefore, geometric navigation is more effective in structured environment, normally in indoor environment, because it is well structured. Most of our obstacle can be represented using a geometric shape. However, when it comes to handling dynamic environment, then it is very challenging. If you because very difficult to represent everything using geometric information. Okay, another category of navigation is based on what we call topological navigation. So this one rely on a topological map. So unlike geometric navigation that rely on metric space, topological navigation focus on the connectivity in places. For example, let's say this one. There is a direct connectivity between stair and toilet. There is a connection between corridor and toilet. Printer can be accessed from the office, and also from the corridor there is a direct connection to the printer area. But there is no connection between printer area and stair, and there is a stair from between the corridor and there is a stair to the corridor. Toilet connected to the office. So this is how topological navigation works. So it model the relationship between nodes. So another representation is similar to this one. Now, what are the advantages of topological network? Scalability. So it can handle very large scale environment, because unlike geometric, you need to create a cell. For example, 100 times 100 square. So that means you need up to 10,000 square for depending on the resolution. But for topological navigation, you don't have to create such kind of map, because you only need to represent the relationship between between the object in the environment. Okay. So the focus is on the relationship rather than the geometric detail of the object in the environment. So it is much easier to understand the topological map. it is more robust to handle dynamic environment. For example, as human, we prefer topological map rather than geometrical map. For example, even in our home, we know that there are, for example, for two-story house, for example, we know that there are two toilets upstairs, another toilet at the ground level. So we don't really need to measure the distance from one point to another point. What we need to know is the relationship between the places. So it reduces the space requirement to store all this information, because you only need to store the relationship between places. Now, because of it is based on relation, so you don't have the information of let's say you want to know the distance travel or the execution time to reach the place. You cannot estimate that because you don't have that kind of information in TN, in topological map. So precise localization is not required. This one is much easier to understand by human. So some example, for example, this one. You have room 1, and then you have room 2, you have object 3, object 4, object 3 is tea table, object 4 is sofa, TV stand. This one is in room 1, and then you have in room 2 you have object 1 and object 2, and they fall under the category of thing, which is one is object and the other one is places. So this is how you represent the environment using topological map. So another example is like this. You have the conceptual map to represent the layout of the environment. Okay, this is how to represent using semantical navigation. Okay. So this is another type of navigation based on semantic map rather than topological or geometrical map. Now you can represent the relationship using semantic. So you have the conceptual map to represent the environment. Now, in comparison to the other two, this one is much easier to human. It is much easier to interpret, very robust to environmental changes. It is very human-centric navigation because we human, we we prefer semantical navigation, semantical map. Now in robot navigation nowadays deep learning is very common. The inclusion of deep learning technology in navigation is very common today. Also the use of reinforcement learning and human robot collaboration. So that means human and robot have to collaborate to solve a navigation problem, and also navigation on a multi-robot system. So for example, swarm robotic and autonomous vehicle and drone. These are some of the area where navigation technology is becoming more important. So in robot navigation, this is the key point: perception, localization, and mapping. Localization and mapping, sometimes you need to do it simultaneously. That's why you call it SLAM, simultaneous localization and mapping. While localizing, you need a mapping. In order to have a map, you need to know the localization. So that's why you need, most of the time you need to do the localization and mapping at the same time. That is why you call it SLAM, simultaneous localization and mapping. So another key point in robot navigation is path planning. So path planning is very important. Deterministic algorithm, you can apply deterministic or undeterministic algorithm. In a deterministic algorithm, it will guarantee the algorithm guarantee to find the solution if it exists, but normally it require very high computational time. In contrast, probabilistic algorithm is much faster, but it includes randomness, and also it does not guarantee to find a solution even if the solution is existing. So that is the main difference between deterministic and probabilistic algorithm. In robot navigation, obstacle avoidance is also a main issue. Of course, motion control, replanning, and the safety. Safety issue is also a main concern in robot navigation. Some of the path planning algorithm, you can download it from GitHub. This is my folder in the GitHub. So all code are in Python, so you can try it out. Let's see the algorithm to generate Voronoi, Delaunay, ESTA, and also artificial potential field. So these are the some algorithm that can be used for navigation. Okay, that's all.
Senator, I just want to